output operations, guys. Last week we practiced this print. So print is for Scala, and if we want to work with Python API, we have to use pprint, and this is the thing we did last week. So for any output, we have been used pprint. It means we want to print out the result, and we have save as text file, and then you can save your result in a text file, and also we will consider it. But these two ones, save as object file and save as Hadoop file, unfortunately they are not available with Python API, and they are available with Scala. And also we can double check now. Let me go through this link. Copy link, and here we go. Let's go here. Oh yeah, they are still unavailable. Okay, no worries, they are still unavailable. And okay, they are still unavailable, but we can consider the rest like this one, for each RDD. Guys, this is really nice operation in data stream. So also you can consider it for the coursework. So what does that mean for each RDD? It means for each RDD that's generating within the time slot, you can apply your own algorithm, your own application. So algorithm application here means your Python code, right? So let's see how we can do that. Let me double check if there is any question. Okay, there is no question. Let me move on. So let's go through this one. Okay, first of all, let's start with output stream. So output stream. So this is exactly, this one, where we are. Yeah, save as text file. So we use print, right, last week, and you could print out, your output. By the way, sometimes we don't need to print out your or result, at the real time, on the screen. You want to record them somewhere. Maybe there are some other applications they want to use your output, right? They want to use your output and then, do a specific task. So to do so, we have to save as a text file. So how to save the result as a text file? Let's consider here. So first of all, load the Spark engine. So these are all configuration. So import libraries, and then use the maximum number of cores in this case. So just log errors. And can you see, guys, here I'm saying take each input every 5 seconds. It means our batches or micro batches are based on 5 seconds. So it means collect data from streaming channel every 5 seconds. So I'm running, and checkpoint is for, this is for fault tolerance purposes, right? Means to log all configuration, and if there is any failure, then it's going to get back to the checkpoint. And can you see that guy checkpoint now has been created here? This is log folder, and if you go through that, it's still empty because we haven't started yet. So then I'm going to say we want to get input from this socket, localhost, this machine, and this port 70/100. So how to run it? Can you see that nc netcat -lk nc? Yeah, it's there. So this is the port I want to open. So what is the task? The task says Flatmap means split line, each line based on a white space, and put number 1 in front of each word, and then reduce by key means then aggregate the result here, because I want to count the number of to calculate the number of words. So if you run it, so can you see that here we said words.save as text file. So before, if you remember, we said words.window, and you have to say the window size is 10 and the time interval for sliding is 5, right? And then you have to run it, or you have to say here like count by window, right? Those window-based operations that we did last week. But here we don't need to use them because we are not considering input as a window. We are considering data as a batch, means every 5 seconds. So if you run and then start, so if you start, I want to go to checkpoint. And as you can see, guys, every 5 seconds, they are coming. Oh, sorry, not checkpoint. Into output. Because here I said go to, save the result into output folder and then count. So we have to go output. And can we see that it's going to say count and then a random number, count the random number. So can you see that, guys, they are generating every 5 seconds. So if I say hi, welcome to this class. So this is the real-time channel, right? We are doing pyspark. Like, let's say do something random. Hi, welcome. That's it. So let's stop the application. And here you can close the port or you can still open it. It doesn't matter because the most important thing is here to stop. So can you see that if we go through the first 5 seconds, can you see, guys, there are 4 files. So who knows what are these 4 files? Every 5 seconds, there are 4 files. Who knows what are these 4 files? Can you see they are empty? Because the first 5 seconds, we had no input. So if we go to, let's say, last one, so it's still empty. This is the last 5 seconds. And also we did nothing. And one before, it seems we didn't have any input. Okay, let's go on. Okay, it says this is talking about the last line we entered, right? It says there are in the first file. It says hi is 1 occurrence, and here it says hi. There are 4 occurrences because here we have 4 occurrences, and so on. And then part 2 empty, and part this is welcome. This is 1, but we have a mistake. This is. But welcome. Let me stop it. So, guys, as you can see, there are the results have been collected inside the file. But as I said, why we need that? Sometimes we need to collect output somewhere because there are some other applications they want to use those outputs. So, guys, we have to consider these 4 files. What they are, guys. As you remember, this is Spark. So since we are working with Spark, means we are working with RDD. So any single line, not any single line, let's say every 5 seconds, because here we said that the time slot is 5 seconds. Every 5 seconds, right, it's going to create the RDD with 4 partitions. So this is one RDD, this is second RDD, another RDD, every 5 seconds, because these folders are RDD. So inside this RDD, we have 4 partitions. At this side, we have 4 partitions. So since this is small size of data, like kilobyte data, that's the reason it's going to generate 4 partitions. But if your data is going to be like megabyte, it's going to increase the number of partitions. So it's going to be set up automatically. So by the way, we have 4 partitions, and that's it. Let me move forward with for each RDD. Okay, for each RDD, let me check the time. Okay, it's good. Okay, data for each RDD. So guys, the name is really obvious. It says for each RDD means here also we have 5 seconds time interval. It means for each RDD, every 5 seconds, do a specific action. So what is the action here? The action is this one. So let's go through that to understand. So again, firstly, make sure to import your Find Spark. So make sure if Find Spark is not there, you have to install it, right? Guys, these are the lessons from last week. But by the way, if you haven't done, you can install again. It says already satisfied, means it's already there. So, and then libraries, and then Spark configuration. So, and then open this localhost. So you can change the port number. So by the way, here make sure to have 80/100, and then you can run it. So you can open the port, and here this is the function. So I want to apply this function over, over data every 5 seconds. So what is the task? So before going through this function, let me run it. So first of all, we have to get data. So guys, this is usually the best practice. Means once you want to start coding Spark streaming, you have to use Flatmap first of all, because the size of data, because data is small. If you remember from week 1, I've said that Flatmap is going to collect all RDDs into one RDD and put them all together. So that's the reason we use Flatmap, because data are really small data. And guys, even if you have like megabyte data, right, you can still use Flatmap, right? I'm talking about, gigabyte, terabyte. That gigabyte and terabyte, they are not fitted. Streaming approach, because streaming means small size of data, kilobytes, megabytes, not gigabyte, not terabyte, because you cannot collect gigabyte, terabyte in a second. So Flatmap means split the lines, and then you have to use this one for each RDD. So again, before we use this one, words, then count by window, or any kind of window, like window, and then you have to say 10 and 5. Mean 10 is a window size and 5 is the slicing window. So, but here we are going to ignore it because we want to use for each RDD. So when you call for each RDD, you have to declare a function. So what is the function? RDD print. So RDD print, get the input. So what is the input? So the input is words. So guys, this is really, the advantage of Python. What does it mean? It means since here we have input like RDD, you don't need to declare it here to say, something. Why? Because it's getting input from words, from the variable. So words.forEach RDD print means send words have been collected from here to RDD print. So we have to check if RDD is not empty, then do it. Map it, adding number 1 in front of each word, and then reduce by key, because we want to aggregate, and then collect them and print them. Right? This is really simple. Let's do it. So let me firstly remove this one. Yeah, let me first remove this one and run again, and start. So I've been started. So can you see that is empty? It has been come up after 5 seconds. So there is nothing, right? Because I haven't entered anything. But if I say hi there, hi, just for test, cn hi there. So can you see it says there are 3 highs, and one there, one. So these are coming every 5 seconds, and another 5 seconds empty. So I want to stop it. So how to avoid this empty RDDs? You can check it by this if. If not empty, then print them out. So how to let me stop this one as well. Just need to press Ctrl+C. So how to run it, how to rerun it, is better to stop the kernel and then rerun it. So I want to remove this one as well. Okay, run, and start. So start, as you can see, we have no empty output, right? If I say hi there, so open the input, then the next 5 seconds we have output, right? Because here we said that if it's not empty, then print them out. So let me Ctrl+C and then stop. Okay, to methods we went through. Let me see what there are. Okay, I want to check if there is any question firstly, and then we can move forward. Okay, Shabanu, is there any question?
Yes, sir. Yeah.
Okay,
So,
go on.
I was just wondering if we can listen from two clusters, like from two ports, and from, or is there any purpose of doing it in real time?
Yes, in this case, you have to declare 2 ports, and then, I mean, if you want to hear from 2 channels,
okay.
Let me see here. If you want to hear from 2 channels, right, you have to, declare it here, like these 2 ports, right?
Mm-hmm.
But if you want to separate the traffic from 7,000 and 8,000, right, then you have to have 2 different sockets. Like, let's say line 1, this is line 2, and then it means you want to hear, inputs from 2 channels separately.
Okay.
And then, yeah, here you have to change it to line 1. Means it's going for line 1, and then you can have something else for line 2. And then, yeah, and then afterwards you can aggregate the result from 2 lines.
Okay.
Yeah, really nice question. Thank you.
Yeah. Another question is, the save as text files, does it save based on the contents, whether if there is any content, it creates a file, otherwise it doesn't?
So this one, output, where we are, not here. Yeah, output a stream. So this one, whatever you have been added as the action is going to add those actions, inside the files. And if you're asking that, what is the main reason of having that? As I said, let's say from my own experience, I've used that because the task was, firstly, I should collect, real-time data from sensors. We have been set up like about 500 sensors. And then the task was to collect all those real-time data coming from sensors. And then before the action, we have to firstly to denoise data, and then remove like duplicates, remove like any words have been collected from sensors. And then it was the action at the real time. At the same time, we had another application, we had another system. It was like a log file system. It was going to read my output and then do another action. It's gonna to collect the numbers from my output and then aggregate it with some other things and do action at real time. So since I have to connect the output of this system to the input of another system. So in this case, yeah, you have to save it somewhere to be an input for another system. We had also another nice question from Tomilola, and she asked, do we always have to use port 7000? No, this is just for practice, because we have to learn, working with data streaming has 2 sides. One side is to how to process streaming data. This is the task we are doing from last week. So we are going to learn Spark to how to process streaming data. This is one approach, or let's say one side. The second side is to how to collect real-time data, right? So for this part, we are working with this port 7000, and there are also other ways to collect real-time data. I want to give you more information about that within this time slot. So let's move on. And okay, and then so we have been working with window-based operations last week, and today we work with for each RDD. And this is also this is really nice method that you can consider it for coursework, for streaming part for coursework. And also I want to repeat, if you go through the samples from last year's students that I've shared in the chat box, lecture 8, so few students used for each, few other students used, window-based, and few other students used a structured streaming that I want to give you, within this lecture. And another way is data frame and SQL operation. It means you can run SQL, over Spark streaming. So this is really nice idea that we can run SQL, because having SQL, we can generate lots of, analytics over real-time data. This is one approach. It says to do so, you have to create a Spark session. So guys, Spark session is the driver for SQL, and Spark context is the driver for RDD and data frame, right? So it says we have to create a Spark session using Spark context, and also we have to done it by the concept called lazily instation singleton instant of a Spark session. So this is the configuration. This is a setup, in Spark streaming, and it says how to do so. Convert RDD of the data stream to data frame, and then run SQL query. I'm not really a big fan of this method, because it's not really user friendly, but I want to give you, information about that. So this one, SQL stream. So as you can see, it says, load Spark engine, load libraries. And here, this is the global instance. So this is the configuration. We have to have it here. So again, I'm just going to give you information about this method, but since this is very restricted method, I'm not going to recommend you this method. Just for, for information, is good to know that. So we have to create an instance, right, to create Spark session out of Spark context at real time. So this is the meaning of that. So then Spark context every 5 seconds. Again, we are using this port. You can change any port. And then this is the task. So as I said, can you see, guys, every time we use firstly this line using Flatmap, because we want to work through the live data. So if we run, and this is the method, and to work with this SQL one, we have to use for each. So words for each. So here, as you can see, for this one, for each RDD, you can use either Python code, like this one that we use Python codes, PySpark codes, or you can use SQL syntaxes. So 2 ways of using a for each RDD. That's the reason I'm saying this is really strong method in Spark streaming. So let's see how does it work. Let me start it, and then we can discuss about the output. So 70, 100. So can you see that is the time coming up? Because here I've said print out, this time firstly, and then try this one. And try and except is the way you can control, let's say, the exceptional errors, right? This is the Python skill, means you can avoid your system get into the crash by using try and except. So here I want to say hider. This is a class hider, something like this. It's really random input. And afterwards, it's going to waiting for the next 5 seconds. So can you see that it's going to count? Let me stop it. I don't want to do more. So as you can see, it's going to count the number of words as as a SQL. Can you see that it's showing up as a table, word and total. So how to do so? first of all, we have to create the instant using get spark session instant. This one that we made it here, this function. So this is a configuration, so we can't change it. And also this is the configuration. So this configuration is the where I'm telling you it's going to restrict us. It's going to say we have to convert RDD to RDD row, means we have to say this is one row. You have to say this RDD is a one row, and then this is another row, third row, right? It says you have to first convert them to row and then convert them to data frame. So can you see it's make it a bit difficult? By the way, these two parts are, let's say, configurations. You cannot change them. So, and then here we have to create a temporary view using data frame and the query, and then SQL query. That's it. This is the thing. So here the most important is this part, your query. You can keep them as they are, right? And then the thing is here, the approach is here to write the SQL. But again, I'm not going to recommend this technique to you. I want to give you the advanced one. I'm not taking this one really seriously. This is just, you know, for your information to say there is something like this method. Okay, let me go through the rest. Yep, let me go. Let me see. Okay, and what else? Okay, stateful, guys, this is really important method, stateful transformation. So stateful transformation is a particular property of Spark streaming. It maintains, this is the thing, it maintains the state between macro batches. So let's see how to work with that and what is that really. So in order to use, I mean, if you want to use this approach, or let's say this configuration, we have to use this method, UpdateStateByKey. So as you can see, since we are talking about key, means we have to create keys and values, right? We have to create like a dictionary, keys and values. And also we have to have checkpointing, you know. And let's see how does it work. I want to give you more information about that to understand it. Okay, so the thing is here I want to do something like this. So this is the channel, right? Int underline underscore values. This is like the lines that we are hearing from the channel. So here I'm using .map. I'm not taking .flatmap. This is just, you know, to change the way of the method. I'm using .map. So what is the map? I'm saying get input, convert it to integer, and get the remainder by 10. So it means 10 remainder by 10 is 0, right? It means 0. Let's say these are my three inputs, first inputs. So 0, 1, and 1, right? Can you see that? 0, 1, and 1. The division by number 10. The remainder is 0, 1, 1. Then .map, x add x1. It means here we have to have this one. 0, number 1 in front of that, number 1, 1 in front of that, 1, number 1 in front of that, right? It's going to say something like this. Okay, we have done till here. Then it says update state by key, update functions. Update function is here. It says new values. So guys, these are new values, right? And what about running count? So since we are running for first time, running count is 0, right? Running count is 0. Or let's say this is null, not 0. This is null. This is null value, not 0. Right? So we have to check if running count is none. Yes, is none. Right? It says running count is 0, and then do summation. New values. So this is new values, and then running count. So guys, sum here is doing over the keys and values. How to do summation? So the key is 0 is just one key, so 0 and 1. What about these two? So since there are two similar keys, 1, you have to do summation of 1 and 1. 1 and 1 is 2. Great. So now this is the output. Can you see that this is the output? So let's say the next 5 seconds, let's say the time interval is 5 seconds. I'm adding, let me change the color of the line, this one, right? Okay. So then let's say I input only this one, 31. This is a new input. So I have to go through this practice. So dot map this one. So this one would be for 31. This is the input. So it should be 1 and 0, right? It says divided by 10. 31 divided by 10 is, sorry, it's, I have to erase and then get back to this. So int x, the remainder by 10 is 1, right? And then dot map, this one, x, put number 1 in front of that. It says 1 and 1. Great. And then update state by key. So to go through that, new values. So this is the new values. Running count, guys, now, oh, sorry. Yeah, running count now is this one. So running count is this one. The old calculations. So running count is the old calculation, and the new calculation like this one, we call it new values. So it says new values, this one, the sum of new values and running count. So we have to do that. So 0, there is only 1 0. That's the reason we have to say 0 and 1. What about another key? We have key 1 and 1. So this is key. And what about the summation? 2 plus 1 is 3. And this is another time slot. And we have to do it, step by step, one by one. So what is the point? The point here is we keep the track of all input from the beginning. So before, once you use window and once you use, for each RDD, it's gonna to consider only the existing time slot, only the existing window, not the older ones, not the older windows. So, but this function, update state by key, it's going to keep the track of all windows, right, from the beginning till end of, the input. So this is nice when you want to have something, over your streaming. Sometimes you need to keep the track of some information from the beginning, from when you start your application. You want to keep some information over the batches. So to do so, you have to use this function, update state by key. So also you can use this function, update state by key, for coursework. As I said, completely, up to you that which technique you prefer to use. And usually, what's happening, based on your contribution for coursework, I try to find, interesting and high-level contribution, and usually invite those students, for paper publication, journal publication. And if I found, there are specific skill sets, and usually ask them to join me, as a TA for next semester. So that's the reason I try to, to pick up those students that they are really, they love this data science. They love, these topics. And yeah, that's the reason. The tasks are really open. They are open, and there is no really consistent, or let's say the exact solution for those ones. I usually try my best to see, which contributions are, let's say, high level, contributing better. So yeah, using these functions, really great. Update state by key. This is really nice method. So as I said, for each RDD and update state by key, these are two strong methods. I really love them. So broadcast. So what does it mean? What does it mean? So broadcast. Okay. So let's say we have lots of batches that we collect them, right, at each time slot. So when we are moving from current time slot, and then we go to the next time slot, and then third time slot, if we move forward through time slots, means the old time slot is gonna be, you know, let's say, gonna be outdated because we will remove them, right? We don't need them because we are working with exactly current real-time data. But let's say over the batches, you want to keep some variables, right? Let's say I want to keep these 3 variables, 1, 2, 3, and I want to keep them over each batches because I want to have it for calculation. So for instance, let's say, let me get back to here. Okay, for instance, here, not this one. Let me go like this one for each RDD. So let's say here, right after the calculation, I want to keep a variable across the next time slots. So how to do so? You have to have this one, broadcast. You have to create a broadcast right here. For instance, after printing, you would say sc.broadcast, and then you can give, you know, your input, you know, because I want to collect them and I want to use them for next time slot and also whenever you need them. So by this solution, you know, you can add it. And once you say sc.broadcast is going to be collected in the driver. Since now we are working on one single machine, the driver and worker both are in the same machine. But if you are working in the cluster mode, you know, running by data centers, then once you create it, it's gonna be added inside the driver because it's gonna be like the global variable across, you know, across the machines. This is nice also, is we have to consider when we can use that. We have another one, but this is not available in Python. So, and since this is not available in Python, I'm not sure why shall I explain it. So, Accumulator, it's like, since it's not available in Python, I'm thinking to how to show it as an example. Okay, accumulator is something like aggregator. So it means at each time, time slot, let's say every 5 seconds. So first 5 seconds, you want to calculate something, right? And then keep that calculation for next time interval. So let's say I want to calculate something and the calculation is 10. I want to send this number 10 to next time interval. So again, do a calculation and let's say the result would be 8, for instance. I want to send this 8 to next time interval. So you want to send the accumulator from first time interval to the next time interval, right? In this case, you can use accumulator. So this is different by broadcasting because broadcasting is going to share a variable across the worker nodes and every single worker nodes, or let's say every single time slot has a unique a unique variable like 1, 2, 3, and they are not going to be changed. But accumulator is going to change the values, you know, across the time slots. But accumulator is not available in Python. Is available in Scala. So, and this is this one, structured streaming. This is really nice method. I love this topic, and let's introduce it. And then I want to give you really more interesting information to see, you know, what we can do with that. So, structured streaming. This is, let's say, advanced version of this SQL one. This where we are, yeah, this one, the advance of this one that I said I am not going to recommend you to take it. By the way, feel free if you think this is easy. You can take it also for your coursework. Just feel free. This is just my personal observation and personal idea on, you know, Spark streaming using SQL. So if you want to use SQL, I usually recommend to use this structured streaming. So a structured streaming, let me also, why not to copy the source, copy link, and also you can go here, right? Structured streaming. As you can see, this is really huge, let's say, library. So there are lots of things that you can do, you know, with this Spark streaming using structure streaming. So by the way, let me take you here. Let's see how does it work. So it says if we have, this is data stream, right? Let's say here we use ncat, nc. This is nc, netcat. So it says whenever you generate data, or let's say you collect data, it's going to add them line by line as a new record. And then if you have another lines of input, it's going to add another record for the table, another record for the table. So can you see that? Another record and another record. So it's going to keep the track of all stuff from your input, from your from your socket input, and it's going to add them like a table, because we are talking about structured streaming, means SQL table, like relational data. So if we move forward, let's see how does it work. It says, let's say we are at first second. If we have data, then you will have your own query and then get the result, right? And it's done, right? Finish. And then next time slot, input, let's say input here is netcat. So your query and then, you know, the output. And just bear in mind, it says complete mode. I want to give you more information. So every second you collect data and then you generate output. And output is going to be accumulated all together, one by one, right? And with this way, you can keep the track of, you know, the input from the beginning till now, right? Let's say you have been started your application, let's say 10 minutes ago, and now at the current time it's going to collect all data have been generated in 10 minutes, you know, within this table. So let me see. Okay. So we have three modes to collect data. So complete mode means the entire updated result table will be written to the external storage. So external storage here is memory, right? Means this one, right? We are adding, you know, one by one. It was this one and adding one by one, adding one by one, one by one. So if we change the configuration mode to append, it says only the new rows appended in the result table since the last trigger will be written. And if we use update mode, only the rows that were updated in the result table since the last trigger. So can we see that you can manipulate your output in terms of the complete mode, the append mode, or update mode, right? So if you use append mode means ignore the old values, the old data, and then just generate the real-time one. But complete mode says, no, don't ignore the old ones and keep all together, you know, in the output. And update mode means if there is any update, if there is any amendment, just print them out in the external storage. Three different techniques. So let's see here. So let's say we are considering complete mode. So the first time slot, can you see, is also saying NC, netcat. So you enter cat, dog, 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 right? Let's say these are the input. So the task is we want to count them. So this is the time interval input, and this is the count. There are 1 cat and 3 dogs. So this is output. Great. So the second time slot, we have owl and cat, right? So owl and cat, since this is complete mode, is going to keep, these two from previous time slot. Exactly, cat, dog, dog, dog. And we have new one. This is the new record. And it's going to count. So then we have another input, time interval 3, dog and owl. So again, we have to keep the rest. Keep the older one because we are working with complete mode. And these are two new ones, and then calculate. So, but if you consider append only the new rows appended in the table since the last trigger. So what does it mean? If you are working with if you want to work with append, so append, how does it work? So it says cat, dog, dog, dog. So this is the first time slot, so it's done, right? So for owl and cat, if we work with append, is gonna to remove these ones from memory and just keep the new ones, owl and cat. And also same for this one, is gonna to remove the old ones and keep the current ones if you are working with append, right? And so on. You can the 3 ways. Also I can recommend you to go through this technique. And guys, this is really wide area, this structured streaming. I can suggest you to go through this guideline, right? Because there are a lot to do. And if you find it out, this is interesting because there are lots of examples that you can consider. If you find it out, this is interesting, you can take it as your dissertation. And I'm really happy to support you, for this data streaming application. And for instance, you can set up like something like Uber using this structured streaming. You can set up something like Netflix using structured streaming. You can set up something like weather forecasting using structured streaming. So guys, I'm giving you ideas about your dissertation. And you can use these kind of applications using structured streaming. And I would be happy to support you in this case. So let me show you the output. How does it work? So 9. So you can test it and you can run it at tutorial session also. Okay, checkpointing, guys, it's not really big deal. Checkpointing means to checkpoint, the output. You can simply run it. Just configuration. And here, I used, this method. I said this is the method. I want to create a Spark context and the socket, and then, this is exactly a previous one. The remainder by 10, put number 1 in front of that. Then here I'm using count by value. So can you see that here I'm using count by value and window. Then print that and also print the count, and that's it. Then checkpoint. The practice was to how to checkpoint. Where is the checkpoint? Is this directory, checkpoint /count. Okay, we can practice it within tutorial session and structured streaming, the last one. Okay, let's see how does it work. So again, run it. Spark session builder app name get or create, run it. So this is the way you have to configure. So Spark read stream format. So we are working with socket, right? For instance, if you want to get data from a Twitter API, you have to use Twitter, but I guess this is Tweet API, something like this, right? And then you have to say, okay, let's first complete this example, and then I will give you more information. So socket. So option means where is the listening port? The listening port is you have to configure it with host. So where is the listening port? Is localhost, means this computer. So if you wanted to listen the traffic from another computer, let's say another IP, you just need to give the IP address. Like I want to hear, the traffic from this IP. So and then it's gonna to hear. So hear the traffic. So and then which port? So I want to hear, let's say, I don't know, let's say 8800. I want to hear the traffic from this port out of this machine from the socket, right? And then load. Let me change to localhost, means this machine. So let's run firstly this one, and then I'll give you more information about the other type of, input for streaming data. So run it. And then here, guys, I'm writing SQL. Can you see that? Select and explode. So explode means get each row and divide them into different, get each line and then put them into separate lines. Means high first line, then their second line, this third line is fourth line, this is the thing explode does. So, and then split them, and then alias, guys, this is SQL, right? This is what I'm saying. Just content. Sorry, the column name is word, and then group by word. This is exactly SQL. So let me, before moving forward, go through this link. Copy. And then paste here. All right. So I'm going to go through Python part. So yeah. So can you see that, guys? It says df select, like device where, and then group by. So these are completely SQL, right? This is one example here. This is another example. You can use like spark.sql. Simply do that. And guys, the rest is your SQL knowledge about that, right? How to use them. And also I can recommend you to go through this configuration. And also I've shared example with you from last year's student. Let me double check. No, this student used for each RDD. What about this one? Yeah, can you see that? Format, no, not this one. Yeah, this one. Where is the configuration? Yeah, it's here. So socket, host, localhost port. And then this is, can you see that this is the SQL code. Group by, count, order by, SQL code. And then, yeah, you can take this example as well. And what else? Let me run it, and this is, let me run, and also I guess the output would be something else. So it's really nice that the output is different here. So if I run it, so it says word count write stream, so I want to write. Output mode is complete. So complete means add the result, back to back. And if you want to change it to append, just simply type append. But I want to go with complete. So format console. So console means here in this console. Since this is input, because here I want to have it like input. Right, and then take output into the console. And also this one, format, here. Okay, let's run it, and I want to give you more information. So, and yeah, let me run it. So once you run it, here also I'm running. So here I'm gonna type hider welcome to the class. No, it's not working. I guess there is error. So let me stop. Replaying tree buffer messages. Okay, let's run again. This one. Okay, start, and then start the port. Okay, can we see that, guys? It's going to say, okay, this is the first result that we have nothing there. If I say, hi there, we are at the class R. So once you enter, so can you see that this is going to work? It means these techniques works after going to the new line. So, and it's going to count. Can you see that I said there are 2 R's, one class with comma, and there. And last year I asked a student to remove these syntaxes. Sorry, these symbols. To remove these symbols because there are 2 class, one class and 2 guys. We have to put them, as one single word. And then, yeah, that's it. And then you can stop. Oh no, sorry, I did a mistake. Okay, here I have to stop. And also here I have to stop. Okay, guys, here I said the format is console, right? Here you can do, different things. Like you can say, save the file inside CSV file, right? And then you have to add the option to give the directory to where to save, right? Like if you want to save it in the Parquet file, you have to give again, the path to where to save. If you want to save the result inside, let's say, I don't know, let's say in a database like SQL, then you have to define MySQL JDBC. Oh, sorry. Yeah, this one, JDBC MySQL. This format gives you lots of, opportunity to save your result, right? And here you say format is socket. So this is the way you have to collect data. You have to collect data from some other sources. Before, checking this one, I want to discuss about, yeah, this one, Spark streaming sources. This is really important. So let me see if there is any question. Shabanu, could you please go on?
Yes, sorry. So the question was about the update by key. The keys are based on the historical data. If that can be, if we are looking at based on the time that's been we are calculating, but if we are capturing the time already, and if we can match the data based on the time that we have captured. So that was my question.
Since we are working with streaming data, we have no really full control of all batches, right? So because the idea of real-time processing is to have small size data, to have kilobytes of data, get them and process them. This is the idea of processing. Real-time processing. So, but if you want to jump between time slots, you have to find out accumulator. Is it helpful? Broadcasting, is it helpful? I mean, this one, broadcasting. You have to match your problem into these, libraries. This update function, this update state by key, is it helpful for each RDD window operations? You have to have all these things, in one basket, and then see can you match your findings with them or not. But just the simple thing is you have to bear in mind that streaming data processing is not really the wide let's say the wide coding space to go through whatever you do with the normal data. No, you have to think, I have batch data at the current time, at the real time, I have to process. Again, I have another batch data at the real time, I have to process. If you want to connect your real-time data to the older ones, it's going to add additional overhead for processing. That's the reason we have no well enough room to do so. It's better to, to consider these availabilities for that.
Okay.
So,
thank you.
You're welcome, my friend. So here I want to give you more information, Shabanu, and then you can consider your solution. Let's say your application within these new sources, right? Within these new sources, you can do the things you want to do, right? Just let me explain what they are.
Yeah, that was my next question too. Like we have Kinesis, Flume, everything we already have, and how Python implementation is going to make a difference.
Yeah, I want to go through that within we are approaching to the end of the session. But guys, please stay with me, bear with me. I want to go through this within 10 or 15 minutes maximum. So Spark streaming. So guys, let me see. Okay, this one. I want to explain this one, then you can understand what is the point. So guys, let me start from here. Yeah, let me explain here. So we, for data streaming, we have a channel. Let's say we have, let's say, a data. So data, let's say real-time data. So the first things we have to think is, how to collect, right? Till now, we used Netcat, right? We use Netcat to collect this real-time data. Then what we did, we have to learn how to process. So here we used, Spark streaming, right? Also within, this week, last week, and today means this week, and we focused more on processing part, to learn how to process them using window-based calculation, DStream calculation for each RDD, broadcasting, structured streaming, and many things, right? We have to catch up with all these topics. And then at the end, we have to use, visualization. And here we usually use pprint, right? We usually use pprint for visualization. So the thing is, we have different type of real data that we have to collect them at real time. To collect those data, for instance, the topic like Uber that I always give this example. So for Uber, we have drivers, right, that they're working based on GPS signal. So we have to collect those GPS somewhere. So who is going to collect all those, real-time data? So Netcat is not possible, right? Netcat is just for, testing, for simulation. So to collect them, we usually use Kafka. So Kafka is, let's say, is a messaging platform, real-time messaging platform. It's going to help us to collect data at real time. So like this one here, that here I said socket, right? Here you have to say Kafka. Means I want to get, data from Kafka server, but here we must be sure. Here we have to import, Kafka libraries, something like this. Okay, so we can use Kafka, and also there are some other ways you can collect data like Flume and also Kinesis. So Kinesis is for Amazon AWS service. Since this is a paid service, and I'm not sure if you have, if you have any promotion if you have account with them. This is free or this is a paid account. So I highly recommend you to go through Kinesis. But Kinesis, since it's a paid, so it's up to you. But I always say these are the topic for your MSc dissertation or PhD dissertations that you can consider these new approaches for data collection. You know, this part, data collection. So we know about, processing, we know about visualization, about collections. We can work with Kafka, Flowme, Kinesis, and there are some other, interesting streaming processing like KStream. So if you want to work with KStream, so KStream, KStream. So KStream itself is, let's say, is a library that you can use it differently as compared to Spark streaming. So KStream is not a part of Spark. It's completely, different platform. So for KStream, I'm working with Java. I mean, the practice I've shown you. So show desktop one, IntelliJ. So working with KStream, right? This is the KStream. As you can see that, where is that? Is KStream, right? I'm working with KStream using Java. So what does it mean? It means okay, it means here, let me change the color, right? So here we have to collect data. As I said, for data collection, we can use Kafka or Kinesis, right? But Kafka is free. So for collection, we can use Kafka or we can use Kinesis. Also, we can use Flume. So, but Kafka is free, Flume is free. Flume is a part of Hadoop ecosystem, and Kinesis is a paid one. So I'm crossing because it's a paid service. And here we learn by Spark streaming. And here, instead of a Spark streaming, you can consider KStream. I mean, these two ones, KStream and KSQL, and also Confluent. You can consider them as a processing phase, Confluent and KStream. So these are the three ones you can consider as a data collector, and Confluent, KStream, and KSQL, you can consider them as the processing. So these are really nice platform, nice, skill sets that you can go through them. So every single advanced sources like these 6 sources, guys, they are really a new world. So Kafka, maybe you need at least 3-4 months at least to practice and learn. Kinesis is same, Confluent, KStream, KSQL. Guys, they are not, I'm not saying they are difficult. No, they are not difficult. They just need to, learn those skill sets. And I always recommend my students, if they are interested in, data streaming skill sets, right? And then you can take your PhD or MSc dissertation with me, and then I will guide you to how to go through these, advanced sources for, your own skill sets. So within this module, you have been learned lots of skill sets, to work with real-time data, machine learning, and so on. And few other students will take big data analytics with me, and then, your skill set would be a complete skill set. And on top of that, if you would like to work with data streaming, and then yes, you can consider, these advanced sources, and we can discuss further. If you are interested, just simply drop me a message, drop me email. So if you want to get idea let's see what is Apache Kafka. Apache Kafka has been developed by LinkedIn 2011. So why they have been done that? Because LinkedIn was facing with, millions of customers. It was difficult to collect all data from customers and process them all at the same time, at the real time. The thing was they were thinking to create the real-time messaging means to complete this, the process between user and, let's say, between consumer and producer, quickly. That was the idea that LinkedIn came from. So many companies use Kafka for different reasons, like Twitter as a part of the storm streaming processing, Netflix for real-time monitoring and event processing pipeline. So Spotify, for log delivery system, and Shopify. Can you see that they are using, these systems? And there are many more, companies, Airbnb, Cisco, and so on. They are working with Kafka. That's the reason. It's free, it's open source, and it's a nice messaging. Let's see how does it work. Then you can think about that for your dissertation. Okay, so I want to give you an example of Uber. So in the Uber, we as a let's say as a passenger, we call consumer. So we are passenger. And drivers are producers. And here broker means who is gonna to serve this service. So here is Uber is a broker. So Uber is going to set up several machines that we call them broker because they have to serve this service between driver and passenger. So they set up Kafka because Kafka is a messaging system collecting data, or let's say transferring data between passengers and driver at the real time. So guys, the thing is at the real time. We are not going to discuss about about historical data. Ignore it, just real time. So then these brokers gonna to talk to each other. So who's gonna to manage all these nodes? Zookeeper. So Zookeeper is a service, right? Is going to synchronize these brokers, to configure these services. And if there is if one broker is gonna to fail, is gonna to crash for any reason, then it's going to manage, other brokers to make them, available. Replications, all these system configuration, hardware configuration have been done by Zookeeper. So Zookeeper is like a leader, right, to lead this cluster. So Uber is a broker, passenger, consumer, and driver as a producer. So we as a passenger, we want to go somewhere. We want to book a driver, right? Uber driver. So what we can do, I am this consumer. I'm this first one. So I have to send my request to broker. So I'm sending my request to the broker. So what is the request? The request is I'm sending my current location and I'm sending my destination location, right? And Uber taking one of these brokers and send my request across the producers, right? Across the producers, the drivers. At the same time, any driver is going to accept my request, is going to send back the approval message. So let's say this driver is sending back the approval message to the broker. And the broker means this Uber is going to process it and send it to consumer to say, okay, there is one driver available. Let's say you can wait 2 minutes, 3 minutes, to get driver at your location. So as you can see, all this stuff has been done within maybe 1 second, 2 seconds, 3 seconds, 5 seconds, means at the real time or at the near real time. So how to process all this stuff? Kafka is let's say a service, is going to do that simply. So all these things are, guys, about messaging, right? Getting message from passenger, sending message to driver, processing, and so on. The thing is, who is going to process all this stuff? So in this case, you can use, Spark streaming. So Kafka is going to combine or manage this messaging between consumer and producer, and then you have to use a Spark streaming for processing. Means to calculate the, let's say, calculate the fare, right? Like the calculate, or let's say the collect the weather for, let's say, I don't know, let's say weather forecasting, and whatever you want to do, you have to use a Spark streaming to process, right? This is collection, this is collection, this is process, right? And then whatever you want, you can visualize, you can print, you can whatever you want, you can do that.